Welcome back to the Math Professors. I'm Professor Van Hamlin and I want to cover Newton's law of cooling and warming. So if you like our free content and you want to help us grow our channel, please consider liking, subscribing, and sharing. So let's start out with the formula. T of t is equal to Ts plus T naught minus Ts e to the kt. So T of t is going to be the temperature after time t. T of s is going to be our surrounding temperature. The initial temperature of the object is T sub naught, and then K is going to be our growth or cooling rate. So we're going to start out with this function here, which is kind of our parent function, the exponential growth function. And we know that y is equal to some, a naught e to the kt, where a naught is going to be really that initial temperature where this thing touches that y-axis. And k is considered our growth rate. Now, growth, because this is going up, it could also be your decay rate if this was, flipped over the y-axis, so if this thing was, decreasing. So, how does this thing compare to the original parent function? Well, this is nothing more than a transformation of that parent function. That this thing right here still represents a naught because it's a thing in front of your exponential, and this Ts is nothing more than a vertical shift up. Now it depends on the sign of this number, if it's going to be positive or negative, to say if it's going to be cooling or if it's going to be warming. So let's do an example. Okay, so here's the example. On Thanksgiving, we remove a turkey from the oven at a temperature of 165 degrees Fahrenheit. After 5 minutes, the turkey cooled 10 degrees to a temperature of 155 degrees Fahrenheit. If a turkey is considered to be cold at 100 degrees or too cold to serve at 100 degrees, how long do we have to serve if my house is a temperature of 72 degrees Fahrenheit? Okay, so first thing we know is that T of t is equal to Ts plus T naught minus Ts e to the kt. So my goal really is to find this k, so that I can eventually solve for a particular temperature. So in order to do that, we have to use some of the given information. So what I know is that the temperature after 5 minutes is going to be 155. So 155 is going to be equal to the temperature of my room, which is going to be 72, plus the initial temperature of the turkey, which was 165, minus the temperature of the room, which is going to be 72, e to the k times how long we waited, which was 5 minutes. Now what this allows me to do is go ahead and solve this thing for k, so let's do some of the arithmetic here. So 165 minus 72 is equal to 93. So 155 is equal to 72 plus 93e to the 5 times k. Then we're going to subtract off 72 from 155, which gives us 83, is going to be equal to 93e to the 5k. Dividing by 93 is going to give me e to the 5k. Taking the natural log of that is going to get rid of that e. And then finally dividing by k is going to give us, 5 is going to give us k. So the natural log of 83 over 93, all divided by 5, is going to equal k, which equals negative 0.0227. A lot of times I like to go to 4 significant figures just to make sure that our time is pretty accurate. Okay, so now that I know my k, what I need to do is I need to figure out how long until this thing reaches 100 degrees. So let's do this thing again. I'm going to use this particular formula with my known k, with this thing equal to 100 degrees. So 100 is going to equal to the outer temperature plus the initial temperature minus the outer temperature, e to the k, which is minus 0.002275 to the t. So my goal really now is to solve this thing for t, and it's done the exact same way that we solve this thing for k. So first things first, we know that this is going to be equal to 93. So 100 is equal to 72 plus 93 e to that minus 0.0, just a single 0, 2275t. Subtracting 72 is going to be 28, is going to be equal to 93 e to the minus 0.02275t, dividing by 93, and then taking the natural log is going to give us minus 0.02275t, And then finally divided by that constant. So the natural log of 28 over 93, all divided by k, is going to equal our t, which equals 35.6 minutes. Again, if you like the free content, please consider liking, subscribing, and sharing. Thank you.